Hi, welcome to Geometry. This is the Unit 2 test prep video, and I'm Mr. McWhorter. Let's go ahead and get started. So we need to find the angle measures and then classify these triangles. Well, we know that all three angles of a triangle have to add up to 180 degrees. So measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180. So we don't know the measure of angle A, but we do know the measures of angle B and C. And that equals 180 degrees. Well, we can combine like terms here. So we know the measure of angle A plus 56 equals 180. And then we just need to subtract 56 from each side of the equal sign. And we get measure of angle A equals 124 degrees. So this is 124 degrees. So we can follow a similar pattern with the next two triangles. We know that angle D plus 52 plus 38, or the measure of angle D, plus 52 plus 38 equals 180. 52 plus 38 is 90. So the measure of angle D plus 90 equals 180. Subtract 90 from each side, and we get the measure of angle D equals 90 degrees. The measure of angle H plus 62 plus 46 equals 180. So the measure of angle H plus 108, when you add these two like terms together, you get 108 equals 180. Subtract 108 from both sides, and we get the measure of angle H equals 72. Now we're going to classify the triangles. Triangle ABC is an obtuse triangle. Because the measure of angle A is greater than 90 degrees. And that's the definition of an obtuse triangle, that there's one angle that has more than 90 degrees. Triangle DEF is a right triangle because the measure of angle D is exactly equal to 90 degrees. And triangle GHI is an acute triangle because all angles are less than 90 degrees. Now the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So as long as the two shorter legs add up to be more than the third leg, I can make a triangle. In this case, in A, I cannot make a triangle because 2 plus 3 is not greater than 5. So this one is a no. And on part B, 4 plus 6 is 10. That is greater than 7. So this one is a yes. Now I need to draw an example of each kind of triangle. A scalene triangle has three sides that have all different lengths. So I have to make sure that I draw a picture that has three sides with all different lengths. An equilateral triangle means equal sides. So all three sides have to have the same length. An isosceles triangle is a triangle which has two sides that are the same length. So if this is 10, then another one has to be 10. So now we're going to talk about congruent triangles. Here we need to draw two congruent triangles that are described. So it says that triangle ABC is congruent to triangle XYZ. AB is 15 units long. BC is 10 units long. There's AC. And then triangle XYZ is congruent, so the point A is going to correspond to the point X. B is going to correspond to Y. So Y is going to be up here. And then Z will be down here corresponding to the point C. And now if these triangles are congruent, we also know that XZ is 9 units long. If these triangles are congruent, that means that AB and XY are congruent, so XY is 15 units long. BC and YZ are congruent, so YZ is 10 units long. And XZ is congruent to AC, so AC is 9 units long. So now we can use that information to do part 2. The length of segment AC is 9 units. The length of XY is 15 units. The length of YZ is 10 units. Now we've got 4 congruence postulates for triangles. The easiest one is usually if all 3 sides are the same length. So side, side, side. And then we got side, angle, side, where you need 2 sides and the angle between them to be congruent. And then we've got angle, side, angle, where you need 2 angles congruent and the side in between them to also be congruent. And then we've got angle, angle, side, where you need 2 angles to be congruent and then 1 corresponding side to be congruent. So in the triangles below, AB is congruent to EF, angle A is congruent to angle D, and angle C is congruent to angle F. Can we prove that triangle ABC is congruent to triangle DEF? Well, let's check to see if we can use one of these congruence postulates. Side, side, side. We only have one set of congruent sides. So side, side, side's not going to do it for us. Side, angle, side isn't going to work for us either because you need 2 sets of congruent sides. Angle, side, angle, and angle, angle, side are the only possibilities because those have 2 angles and a side. In order for angle, side, angle to work, we would need the side in between the 2 angles to be congruent. So we would need AC congruent to DF. And we don't have that, so angle, side, angle is not going to work. Angle, angle, side, we would need, if we were going in this direction, angle C, angle A, and then side AB, we would have to go angle F, angle D, and then side DE. So the congruent sides that we have are not in corresponding places. So we're not able to prove congruence. So one way you could explain that is to say that we don't satisfy any of the four postulates. Another way you could say is, what would you need? We would need segment AB congruent to segment DE to use angle side. Let's go ahead and take a break right now, and we'll finish the rest of this practice test on the next video.